Refrigeration is a process of cooling which operates on the principle of the absence of heat. It is a thermodynamic process because it deals with exchanges of heat. In refrigerators, there is a liquid called the refrigerant, which acts as a medium through which heat can be transported out of the system and into its surroundings. The refrigerant liquid first travels through an expansion valve, or throttling device, where its pressure drops. This drop in pressure permits it to vaporize, and thus the temperature of the remaining refrigerant decreases. The liquid enters evaporator coils within the fridge. Here, the liquid further vaporizes as it absorbs heat from the fridge, converting it into a gas. It then goes through a compressor, where both its pressure and temperature increase. After going through the compressor, the refrigerant passes through condenser coils on the outside of the fridge, allowing heat to pass into the colder surroundings. The refrigerant changes back into a liquid, and then the cycle starts over again. Microwave ovens also operate through a thermodynamic process. The microwave oven contains a magnetron, a vacuum tube facilitating the movement of electrons. The magnetron essentially generates microwaves from electricity. First, a transformer converts electricity of 120 volts from the wall to about 4,000 volts. The high voltage heats a metal filament, in turn boiling off electrons. The electrons produced start rushing toward a positively charged electrode called an anode. However, two ring magnets force the electrons into a circular path. As the electrons whiz by cavities in the anode, they produce microwaves. Next, the microwaves are transmitted into the cooking compartment through a waveguide, which is a passageway in the wall of the microwave oven. The waves bounce around until they penetrate the food. The positive ends of water molecules in the food align themselves up with the microwave's electric field. Though, because this field reverses about 2.5 billion times a second, the water molecules twist, vibrate, and rub up against one another, creating heat. This process simultaneously cooks the outside and inside of foods, unlike conventional ovens. The UConn cogeneration power plant is a good example of a gas turbine in action. In fact, I learned about it last week as I had the chance to get a tour of the fascinating facility with one of the on-campus clubs. The combustion turbine generators in the plant are run mostly by natural gas, though in the winter they run on diesel instead. In the combustion generator, a compressor draws air into the engine and pressurizes it. As the pressure increases, so does the temperature. Then, fuel is injected into the combustion chamber. The fuel mixes with air in a combustion reaction, and then the hot gas moves through the turbine blades, forcing them to move very rapidly. The turbine captures energy from the expanding gas, causing the drive shaft, which is attached to the generator, to rotate. The generator contains a large magnet surrounded by coils of copper wire, producing the flow of electrons, which is known as electricity.